System administrators to cyber defenders to even pen testers use SSH. If you don't understand SSH, you're missing out on a core tool, and it'll hurt your performance at work and possibly even your job prospects. So why is SSH so useful? Well, picture this. It's 2 a.m. The production server is failing. You're at home and the data center is 1,000 miles away. The question is, how can you fix a computer you can't physically reach safely without anyone observing or tampering with the connection? I had this scenario happen to me not once, but twice in my career, and both times Secure Shell or SSH was the tool that I used to fix the server. Cool, you say. SSH really saved your bacon. But what does it actually do that made you want to use it? Well, I wanted to use SSH because it gives me an interactive terminal on a remote computer far away, and it keeps my connection safe from hackers via an encryption tunnel. Now, if you analyze what I just said, you'll come to the conclusion that it's technically correct, but technically correct often doesn't help us understand a new concept. Plus, it was kind of jumbled and it had a lot of tech jargon in it, so it failed to paint a clear picture for us, and that's an absolutely terrible way to learn something new. So let's start simple with a core concept and build our way up to that technical level of understanding. Now, SSH sounds advanced, but the core idea can be explained very simply. Let's do that right now using an analogy. Imagine you need to do work on the other side of a lake. You have a work truck, but there's no bridge or boat to get you to the other side. Instead, there's a magic tunnel that goes through the lake, letting you safely drive your truck to the other side and do your job, all without getting wet. In this analogy, the lake represents the dangerous public internet, and the magic tunnel that prevents you from getting wet is the encrypted SSH connection. So the basic concept is, perform work on something that is physically far away from you while minimizing the dangers. Now, if we start stacking technical details on top of a shaky core concept, the whole thing is going to fall apart because those details lack the solid framework to attach to. So before we dive deeper, let's really lock in that core concept with another analogy. You're at work, but your pet dog, who for some reason you named Computer, is sleeping at home. You want to give your dog some commands like sit and roll over, but your house is 20 miles away from your office, and Computer lacks the required opposable thumbs to operate a cell phone. So you take what is obviously the simplest path forward and you open a portal in space-time between yourself and your dog at home. And you begin shouting commands to him. Computer, roll over, you yell into the portal. Computer, sit. Computer, get yourself a biscuit. Staring into the portal as you give these commands, you are able to observe Computer responding to your commands according to his training. After you're done, you close up the portal, feeling good that Computer was able to complete the tasks you gave him and even get himself a biscuit as a reward. This example is analogous to SSH because you were able to give Computer commands from a remote location. And since no one knows how a portal in space-time actually works, besides you obviously, no one outside of your office or house could observe what you and Computer were doing. In the same way, SSH allows us to work on computers far away from us while minimizing the dangers of being hacked or even observed. Now, analogies are fantastic for understanding new concepts, but to really understand technical subjects, these core concepts must have specific details built on top of them. So let's ratchet up the technical detail by a notch by answering these two questions. Number one, how does SSH actually connect computers over long distances? And number two, how does SSH protect my connection from hackers? First, we'll explain how SSH connects computers over any distance, long or short, since the process is the same. And that process requires 5 basic items: an SSH client computer, an SSH server computer, 2 IP addresses, and a port number. Let's quickly explain each of these. A client computer is one that reaches out to perform work on another computer. It's the one that physically sits in front of you and initiates or asks for the SSH connection. The server computer is the one that waits or listens for a client computer to ask for a connection. Servers typically do not ask for SSH connections, but when they detect a client computer with proper credentials asking to connect, they'll accept it and the SSH connection will be established. Now let's talk about IP addresses. An IP address for a computer is equivalent to a home address for a house. An IP address tells other computers on the network where to find it. For an SSH connection to be successful, each computer involved must have an IP address and the knowledge of how to reach that address. Now on to ports. In the context of SSH and often in networking, the word port does not refer to a physical port. We simply use the word port because it's a good word to describe the general behavior. The port is actually just a label the operating system uses and is better described as an ID number the OS uses to route network traffic to the correct program. Here's a better example. Think of a server as having multiple doors. Each door gives you access to a different application or program on that server. Behind door 22 is SSH, behind door 80 is a website, and behind door 53 is DNS. So when we reach out to port 22 on a server running SSH, we are asking the server to serve us an SSH connection. Now that we've described all the parts, how do they fit together to create an SSH connection? First, the SSH client computer and the SSH server must each have an IP address, and they must know how to reach each other's IP addresses. Then, the SSH client computer reaches out to port 22 of an SSH server. If the client computer presents the SSH server with valid credentials, the SSH server creates the connection. This is all fine in theory, but it's still just a theory, so let me show you what this looks like in real life. Here is your basic SSH connection. I am on an SSH client at the moment, and I'll type in the following command. SSH, for the SSH command, Vero, which is my username, and then I'll type the IP address of the SSH server. And then I'll hit enter. It'll ask me for the password to access the SSH server. And I'll type it in here. And there you see at the bottom, I am now connected to an SSH server called Ubuntu Target. And then to get out of it, I can just type exit. And so if we clear our screen, you can see again, SSH, username, at IP address of the SSH server. Enter the password, and that's all it takes. Great. Now we have a good idea about how SSH connects, but we're still missing an integral piece of the puzzle. How does SSH protect us from having our activity observed or even from getting hacked? SSH's security is the other big reason it's so widely used. So let's break down how it works. First, we need to understand encryption. To understand encryption on data flowing through the internet, think of cars driving down a highway. If a car has regular windows, you can see the occupants inside. You can see how many people are in there, whether they're on the phone or eating McDonald's. But if a car has heavily tinted windows, your view is generally blocked. You can't tell who's inside or what they're doing. Encryption works the same way for data traveling across a network in little containers called packets. Sure, you can still see packets moving across the network, but you cannot see what's inside because the packet's contents have been encrypted. Encryption works like the window tint on the car. It obscures the contents of the packets. Now, how does it do that though? It runs the contents of the network packets through a math formula that scrambles it, making the contents unreadable to anyone except the intended receiver. Going back to SSH, SSH makes sure the data from the client computer to the server computer is encrypted. So even if someone saw the data traffic, they could not read it anyway. So they can't capture any sensitive data like usernames or passwords traveling from the client machine to the server machine. They can't even see the work you're doing, which is awesome. And that's it. Now you know what SSH is, why it matters, and when to use it. In the next video, we're going hands-on with real SSH commands, and I'll explain what every piece means. Follow this series and you'll be an SSH wizard and the expert in your group of friends and coworkers. And thanks for hanging out with me, and we'll see you in the next one.